All right, welcome into 9.4 notes. We're going to be talking about inscribed angles. So an inscribed angle has a vertex on a circle and sides that contain chords of the circle. So if I take a look over here, I have angle A, C, B. That is my inscribed angle. As you can see, angle C right here is on the circle. An intercepted arc has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. So if I take a look, I see that arc AB right here, this arc is that intercepted arc. A is an endpoint on the circle, B is an endpoint on that circle, and arc AB right here is that intercepted arc. It is swooped out by the endpoints of the angle. There is a theorem about an inscribed angle. It says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So here the measure of angle 1 will be half the measure of arc AB. So for instance, if arc AB was 50, cut 50 in half, that means angle 1 would be 25. And if I want to know what is the measure of the arc AB, if I know angle 1, so if I know angle 1's measure and I say that angle 1 right here is 25, recall, then all I have to do is double the 25 to find the arc. So the measure of the arc is twice the inscribed angle, or the inscribed angle is half the measure of the intercepted arc. So let's get to some examples. Let's try these problems and see how we can handle them. So first off, example number 1, it says I need to find the measure of angle X. So if I wanted to find the measure of angle X here, I'm going to take a look, and I see that angle X is swooped out by arc ZW. So I know the measure of that arc, so the formula says that the measure of angle X, so the measure of angle X is equal to 1/2 the measure of that intercepted arc, or half of 86. Half of 86 is 43. So the measure of angle X is 43 degrees. Looking down here, I need to find the measure of arc XY. So if I look right here, X to Y is that arc that I want. So the measure of that arc, so the measure of arc XY or YX, I don't want to have the angle, it should be the arc, so pardon me. So the measure of arc YX is equal to 2 times the measure of the inscribed angle, or 2 times 52, which is 104 degrees. Come over here, look at example number 2. I need to find the measure of angle C. So again, the measure of angle C is going to be half of the intercepted arc. So half of arc AD. So half of arc AD, half of 94 degrees, is going to be 47 degrees. If I want to find the measure of arc BC, so the measure of arc BC here, that is equal to 2 times the measure of 48. So 2 times 48, that means it's 96 degrees. Moving on to our next theorem, theorem 9.7. It says if 2 inscribed angles of a circle intercept the same arc and or congruent arcs, then the angles are congruent. So if I take a look, I'm going to highlight here this arc. If I highlight that arc, that's my intercepted arc. If I highlight right here, I see that angle 2 And I also see over here that this 38 degrees right here swoops out that same arc. So if I wanted to find what is the measure of angle 2, well, angle 2 is going to be the same as that angle down here that swoops out the same arc. So I see that angle 2 is also going to be 38 degrees. If you didn't like that, you could have taken 38, times it by 2, found out that this arc is 76 degrees, and say, okay, well then the measure of angle 2 is 1/2 of 76, and you get 38. That's the long way, but just understand the shortcut. Carrying on to example number 4, I'm looking here and I see that, man, I'm looking at arc GH right here, and I see that the angle that is swooped out, I got angle GJH, and I also have over here angle HIG swooping out that same arc. So therefore, I know that these angles are congruent. So I'm just going to write an equation. I'm going to say that 8x plus 9 is equal to 10x minus 1. Solving for x here, I'm going to add the 1 to both sides. I get 8x plus 10 equals 10x. I subtract my 8x from both sides. I get 10 equals 2x. Divide both sides by 2, and I get that 5 equals x. So we're not finished because they want to know what is the measure of angle I. So the measure of angle I is equal to 8 times 5 plus 9. That is 40 plus 9, which is 49 degrees. Theorem 9.8. It says an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So if we were to take a look, we know that this arc FJH, that's a semicircle. I know that because FH is a diameter. So according to our formula, if that's 180 degrees, then that means that angle G is half of 180, which is 90 degrees. That's it. So that's theorem 9.8. It's kind of common sense. So here, if I'm asking you, okay, what is angle 1? Well, I know that angle 1, this is a diameter right here, this segment. So that means angle 1 is just 90 degrees. Again, we have some skills that are available to us. We know that a semicircle is 180, so that means this arc is 140 degrees. Again, I have a semicircle going from here to here, and if I know that's 70, that means that this piece right here is 110 degrees. So I could say, okay, I have an arc that goes from here to here. That whole arc is 180, and I could just divide 180 by 2. You're still going to get 90 degrees. Carrying on with this bad boy, we're going to take a look and see, okay, well, this is a semicircle. So that means that angle F right here is 90 degrees. So I'm going to go on and say that that angle is 90 degrees. So if that's 90, I know that these other two angles have to add up to be 90. Or if you want, you could write it out the long way and say that 2x plus 6 plus 8x plus 4 plus 90 has to equal 180 degrees. Again, why did I do that? If I get my pointer out, I know that all of these angles right here form a triangle, and all triangles add up to 180 degrees. So we could just go on and combine our like terms. 2x and 8x is 10x. I know that 6 plus 4 is 10, plus 90 is 180. So that means 10x plus 100 is equal to 180. That means 10x equals 80. Divide both sides by 10. I get x is equal to 8. But that's not what they want. They want me to find out what is the measure of angle D. So the measure of angle D is equal to 2 times 8 plus 6. That's 16 plus 6, which is 22 degrees. All right, last page of our notes. It says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So I need to have a quadrilateral. I don't know why the picture right here is off, so please ignore this picture. That does not do us justice here in this circle. I have no idea why the picture is off. So what we're trying to say is if I have a circle and I have some sort of four-sided figure that lies on the inside of this circle. So there's my four-sided figure. And I said that this is angle 1, angle 2, angle 3, and angle 4. That means that angle 1 and angle 3, so the measure of angle 1 plus the measure of angle 3, they'll equal 180. And that also means that the measure of angle 2 plus the measure of angle 4 will equal 180. So angles that lie across from one another will be supplementary. So in my picture, this guy's a little bit, it's taken a lot of kind of information that we need to put together to help us solve for this problem. So luckily I have a diameter drawn in. So if you guys see right here, I have this diameter drawn in this picture in my example. So that's good to know, because that means I already have 80 degrees. So that means this arc from here to here has to be 100 degrees. So all I have to do is write in what its measure is, so that's 100 degrees to help me out. If I look, I have 60 degrees for this arc. So that means that the other arc that forms that semicircle, I'll highlight that in a different color. Let's get right here. From here to here, that arc right there is 120 degrees. So that's helpful. I'm going to go on and erase all these colors here, hopefully. Well, it's not allowing me to erase, but that's okay. There we go. So now I could go on and figure out each one of these angle measures. And all I need to do is figure out one. So I'm going to look at angle 1, and I know that angle 1 is swooped out by a diameter. So that right here is going to be helpful for me. I know that angle 1 is going to be 90 degrees. So angle 1 is 90 degrees. It is half of that 180. Well, angle 1 and angle 3 have to add up to be 180, so that means angle 3 is 90. Now, the reason why I went in and found out these angles, or the arcs, is because right here is angle 2. And we know that angle 2 is half the measure of this intercepted arc. So it goes from here to here. So what is half, or half of 220? So angle 2 is 1/2 of 220, which is 110 degrees. So if that's it, that means that angle 4 is going to be equal to 180 minus 110, which is 70 degrees. I didn't have to start there. I could have started with angle 4 if I wanted to. And if you look at angle 4 is formed right here. So 60 and 80 is 140. So I could have said it is half of 140. And half of 140 is still 70. Algebraically, what do we know here? We know here that the measure of angle U plus the measure of angle T will equal 180. Angle U is 14x. I know that angle T is 8x plus 4. That is 180. 14x and 8x is 22x. Plus 4 is 180. I'm going to subtract the 4 from both sides, so we get 22x is equal to 176. I'm going to take 176 and I'm going to divide it by 22, and I get that x is equal to 8. So now that I know that x is 8, I could find that the measure of angle T or U, whatever I wanted, but that's not what they're asking me. They're asking me what is the measure of angle S. So I know the measure of angle S is 90 because opposite sides right here. If this angle is 90, which it is, that means S is 90. So now the measure of angle T is 8 times 8, because that's what x is, plus 4. That's 64 plus 4, which is 68 degrees. That's it for our notes. Please check Schoology for the assignment and the problems that you need to answer from section 9.4.